kids, Miss Kulkarni here. So in this video, we are going to use stoichiometry as a model and we will learn basic conversions from moles to molar mass, particles and also volume of gases at STP. And we will discuss more about what STP means. So let's begin and work on our next calculations. But before that, what is a mole? We did cover this earlier, but just as a refresher, a mole is a unit. It's a basic unit used in chemistry. And this is just like a counting number. The way we call 1 dozen is equal to 12. So same way, 1 mole has some meaning. So any chemical compound, if we have 1 mole of substance, that means we can tell that we have these many particles, and that is our Avogadro's number, 6.022 10 to the 23. It's a big, huge number, but that's what we can tell if you have 1 mole of any chemical substance. Then the molar mass is mass of 1 mole of substance, and we can relate these two things together. So what do we mean by atomic mass or the molecular mass? When we use the word atomic mass, it goes back to the element. And when we use the term molecular mass, we are talking about a compound which could be covalent or an ionic compound. So this represents actually the mass in terms of grams for 1 mole of either an element or a compound. Now, molar masses are usually calculated using, of course, periodic table, and we count those to the 100 places. The unit for molar mass is often used as grams per mole, or we also can use AMU, which is atomic mass unit. Now, the atomic or molar mass is, again, one more time to repeat that, it is the mass of 1 mole, or how many particles is that? 6.022 10 to the 23rd atoms of a substance. So I am pretty sure you will not forget what 1 mole stands for. Let's talk about some diatomic elements. The word di, what does that mean? That means it's 2. So in our periodic table, we have 7 elements which are diatomic elements. And these are iodine, bromine, chlorine, fluorine, oxygen, nitrogen and hydrogen. All of these are considered as what kind of molecules? Covalent molecules. Well, these are 7 elements, and how can you remember these in easy way? Here is the trick. You can remember the simple easy phrase, I bring clay for our new house. Or you can say, I bring clay for our new house. Well, if you remember, doesn't matter which way you remember. Mole is always the heart of chemistry. And we discussed this earlier, but just to refresh our memory, mole can link to the mass through the molar mass. And mole can link to particles through Avogadro's number. Let's talk about how we calculate the molar mass for any given substance. Here's an example. We got cyclononane. Nonane stands for carbon atom equal to 9. And if it is cyclo, that cyclo means you are going to use the formula CnH2n. So what's the formula going to be? It will be C9 and hydrogen will be 9 times 2, it will be 18. So we got C9H18 as our formula for nonane. Oh, of course, cyclononane. And now, in order for us to find out the molar mass, we need to make sure we start with the number of atoms which we got. So let's calculate the molar mass for C9H18 now. So we got 9 carbon atoms times we need to have the molar mass for each carbon atom, which is from periodic table. So we're going to multiply 9 times 12.01. which I believe we got 108.09, and then we got hydrogen atoms, which is 18. So 18 times it is 1.008 is the atomic mass for hydrogen. When I multiply, what I get is 18.144. When I add these things together, what do I get? I get 126.234. And of course, the unit for that you can write down as AMU, or it's grams per mole. Okay, let's find out the molecular mass of bromine now. Remember, bromine is one of those diatomics. I bring clay, so that's the bromine. So we have 2 atoms of bromine in bromine molecule. So let's do our calculation now. We got 2 atoms times, it's going to be each bromine atoms, the atomic mass is 79.90, and that equals to 159.8. So it can be again grams per mole, or you can also use AMU as the unit. So that's it. The only steps we have to follow is to get the correct formula for the compound and use the number of atoms, multiply those by the atomic masses, which you can find from the periodic table, and just multiply and add, and there you go. You got the molar mass of the compound. So let's move on now from moles to mass and mass to moles for compounds. So here's our first example. Rufus has measured 79.83 grams of a compound, which is tetraphosphorus decoxide. What does tetra stand for? Tetra stands for 4. And what does deca stands for? That stands for 10. So your compound will be phosphorus, which is tetra, that's 4, and oxide, O, will be 10. Our next step is to find the molar mass for our compound. So we got 4 atoms of phosphorus, that times the atomic mass, which is 30.97, and we get that as 123.88. And then we got oxygen, 10 atoms, each one is going to be 16, and when you multiply that, we got 160.00. There we go. We add both those things and we end up getting 283.88 as the molar mass. Our next step is going to be converting the given mass into moles using molar mass, which we just calculated. So what's our roadmap going to be? It's going to be grams to moles. Just one step roadmap. Let's put into our grid. This is our grams, and that's going to be moles. Grams is the given, which is 79.83 grams. And then crisscross we need to cancel. So that becomes grams. Remember what we always said, mole is always number 1. And when it says grams, that is the molar mass of the compound. So the units grams get cancelled, and what we end up having is actually the moles. So when we divide both those numbers, we are going to get the answer, which is 0.3342 moles of P4O10. So what do you think? Let's do one more example for practice. So here is Bill, and he has 4.7 moles of fluorine. And we need to find out how many grams of fluorine does he have. Remember, fluorine is one of those diatomics, F2. Okay, I bring clay for our new home. So it's 4. 4 is going to be F2. So that means we have 2 atoms of fluorine, and each fluorine is 19.00. So what we got is 38.00 AMU, or we can say grams per mole. And now we need to convert from moles to grams. So here is our simple roadmap going from moles to grams of fluorine. Let's put that into our dimension analysis. So there is our moles. This is grams of fluorine. And in order to cancel, we need to get moles over here. We begin with what is given, which is 4.7 right over here. Mole is always number 1. And when it's grams, we are going to put that 38.00 over here. So moles units get cancelled and we multiply and we get our answer. And that answer is 0.12 grams of course, fluorine. What do you think? Is it getting easier now? Let's try now moles to particles and particles to moles. Again, we did this for the element. Let's try to work on this again with compounds. So remember, from moles to particles, we use this big fat number, and that is Avogadro's number. How many molecules are there? Remember, the atoms, molecules, all of these are nothing but particles present in a compound. Here is the beautiful thing. You can write down the compound formula. Carbon dioxide. There is nothing means one carbon. Di stands for 2. It's CO2. The main thing to remember is we don't really need to find the molar mass for moles to particles because we are not going to use molar mass. We are going to use the Avogadro's number. So it saves you one step. So what's our roadmap? Is going to be moles to particles. Let's draw our grid. And what we have is moles over here. And this is going to be particles. Crisscross, we need to cancel, and that's going to be moles. Number of moles is 0.00375. Remember, mole is always number 1, and for particles, it is 6.022, 10 to the 23rd. And then moles are cancelled. We will just multiply and get our answer, which is 2.26. 10 to the 21, and so many molecules. You can also put molecules as MlCl just for your information, and that is for carbon dioxide. Let's work on one more problem for practice. So this one is we need to find how many moles of propane are present in so many molecules of propane. Molecules is again nothing but particles. Propane has how many carbon? It will be 3. And then the formula which we are going to use is CnH2n plus 2. So how many hydrogen is that? It will be 3 times 2, which is 6. 6 plus 2 will be 8. C3H8. Now, although I am writing the formula, we are going from moles to particles. So there is no need to find out molar mass. So please do not spend your time in calculating molar mass if you're going to particles. Let's get our roadmap, and that will be particles going to moles. Just one step. That is our particles. That goes to moles. And then in order for us to cancel, we need to have particles here. Let's begin with our given particles, which is right over here. Mole is always number 1. And then this one, if it's a mole to particle ratio, what do we write? It's always the Avogadro's number, 6.022, 10 to the 23rd. The unit particles is gone, goodbye. And then what we get is the answer in moles. Remember, when you are calculating, don't forget to put the parenthesis, otherwise you may end up getting a wrong answer. So here is what I got. 7.56 moles for propane. There we are. So what do you think? Isn't this easy to use simple stoichiometry or dimensional analysis and do these conversions? I hope you guys enjoyed the video. I will see you again in next video. Until then, bye-bye.